Example 5 says, assume 6 sine squared minus 7 cosine squared equals 1. Find the value of cosecant squared of x. So we said, right, the unit circle only defines things in terms of sine and cosine. But part of the issue with the unit circle is x squared plus y squared has to equal 1. So if all the x values, right, so I'm just going to write this down here so we can see it. If all the x squared values on the unit circle correspond to cosine, right, then we can call that cosine squared. And all the y values represent sine, so I'll square sine. That has to equal 1. So this is actually an identity, and we're going to see this come up again later. So cosine squared of something plus sine squared of the same thing is going to give you 1. So that means if I look at this formula and I want to find cosecant squared, well, we also know that cosecant squared of x is 1 over sine squared of x. So if I can just solve this equation for sine squared, then all I have to do is flip it upside down to get cosecant. So that means the first thing I need to do is I need to eliminate the cosine squared from the equation and isolate sine. So I can actually use this identity right here. So I'm going to leave the sine squared alone. And then I'm going to take cosine and I'm going to replace it with 1 minus sine squared, right? So if I move the sine squared over, I've just got cosine squared. So we'll say 1 minus sine squared x, and this still has to equal 1. So now I'm going to distribute out the 7. So 6 sine squared x minus 7 plus 7 sine squared x equals 1, because it's negative 7 times this negative sine. I have a 6 sine squared and a 7 sine squared, so that's 13 sine squared. I have a negative 7 that I'm going to add over to my 1, and that makes this 8. So sine squared x equals 8 over 13. So that means cosecant squared x is 1 over this. So we flip the fraction, and now we have this. I could have given you the same equation and said find secant squared. Well, secant's 1 over cosine. So then we would have replaced sine to get everything in terms of cosine, solved it, and then we could have flipped the final answer to get secant squared. Number 6 says, give the locations on the unit circle where the following quantities are undefined on the interval from 0 to 2 pi. So undefined means we cannot evaluate. So the easiest thing to do when we're talking about the unit circle is take everything back to sine and cosine, because that's how things are listed. So secant is 1 over cosine theta. Tan is sine theta over cosine theta. Cosecant is 1 over sine theta. And cotangent is cosine over sine. So these are all fractions, and a fraction is undefined if its denominator is 0. So the first guy has a denominator of cosine. So if I go back to my unit circle, remember cosine are the x values, and I want to see, well, where are the x coordinates 0? And they're only true here and here. So at pi over 2 and 3 pi over 2. So that means wherever theta, right, is pi over 2 or 3 pi over 2. Well, tangent, if we look down here, also has a denominator of cosine, so that means it's also undefined at pi over 2 or 3 pi over 2. But these two have a denominator of sine. So if I go back to my unit circle, I see that y is 0, right, on the x-axis. So notice my interval was 0 to 2 pi included. So we see we get 0 at 2 pi, 0. We get 0 at pi, And then when we continue around, get back to 2 pi, we get 0 again. So there's actually 3 answers here. 0, pi, and 2 pi. So this one will also be 0, pi, and 2 pi. Now there's one other pattern I'd like you to see here. If you get confused about does secant belong with cosine or sine when you flip it upside down, the way I like to remember it is the s's and the c's go together. So secants turn into cosines and vice versa. Cosecant starts with a c and it turns into sines. So the trig functions that start with s and c go back and forth with each other.